this presentation, I give an overview of dimensionality reduction algorithms. As the summary of this presentation is the following. I will start by analyzing what it is dimensional reduction and the two perspectives of feature extraction and feature selection. Then algorithms of feature extraction and feature selection are presented as and also how they are presented or implemented in scikit-learn. Like clustering methods, dimensional reduction seeks and exploit the inherent structure in the data. And as well as clustering methods, it is an unsupervised way to summarize or describe data using less information. In the context of dimensional reduction algorithms, we have feature extraction and feature selection. Those are just some of the most used algorithms for dimensional reduction. Principal components analysis, linear discriminant analysis, non-negative matrix factorization, and truncate singular value decomposition. Principal components are new variables that are constructed as linear combination of mixtures of the initial variables. These combinations are done in such a way that the new variables, the principal components, are uncorrelated, and most of the information within the initial variables is it's squeezed or compressed into the new components. As there are as many principal components as there are variables in the data, principal components are constructed in such a way that the first principal component typically have a large part of the variance in the data set. Computing the eigenvectors and ordering them by their eigenvalues in descendant order allows us to find the principal components in order of significance. The aim of the last step is to use the feature vector formed using the eigenvectors of the covariance matrix to reorient the data from the original axis to the ones represented by the principal components. This can be done by multiplying the transpose of the original dataset by transpose the feature vector. Principal components analysis, or PCA, is a dimensionality reduction method. It is often used to reduce the dimensionality of large datasets. The purpose is transforming a large dataset of variables into a smaller, containing most of the information in the large set. The whole process of obtaining principal components from raw dataset can be simplified in a couple of steps. We have to take the whole data set, then we compute the mean for every dimension of the whole data set, then we compute the covariance matrix of the whole data set, and we also compute the eigenvectors and the corresponding eigenvalues. And we sort the eigenvectors by decreasing eigenvalues and choose k eigenvectors with the largest eigenvalues to form a matrix. It is important to consider that the eigenvector is a vector which doesn't change direction when linear transformation is applied. Then these eigenmatrices actually have previously calculated. We use it to transform the samples into the new subspace. So this is generically what happens with PCA. Uh, the kernel PCA is an extension of the principal component analysis using techniques of kernel methods. This is used in the specific situations where we don't have linearity between the dimensions. We may see an example how to use scikit-learn in order to apply the PCA. First step, it is quite easy. It is just to create um, an object. It is PCA, and then we have to use the fit and transform methods. Both linear discriminant analysis and principal components analysis are linear transformation techniques that are commonly used for dimensionality reduction. Linear analysis seeks to best separate or discriminate the samples in the training dataset by their class values. Specifically, the model seeks to find a linear combination of input variables that achieve the maximum separation of for samples between classes. Those are the classes means or eventually centroids, and the minimum separation of classes within each class. The implementation in scikit-learn is very similar to the implementation of PCA. The non-negative matrix factorization is an unsupervised algorithm that projects data into lower dimension spaces, effectively reduce the number of features while retaining the basic information necessary to reconstruct original data. NMF decomposed multivariate data by creating a user-defined number of features. NMF uses an iterative procedure to modify the initial value of W and H so that the product approaches V, matrix V. The procedure terminates when the approximation error converges or the specified number of iterations is reached. In this example, it is presented the way how it is implemented inside scikit-learn. It is very similar to the other example. In this case, we create an object, MF, with the number of components that here it is 2, and then we'll fit and transform data. Truncated singular value decomposition, or truncated SVD or TSVD, is a matrix factorization technique that factors a matrix M into the three matrices U, sigma, and V. This is very similar to PCA, excepting that the factorization for SVD is done on the data matrix, whereas PCA, the factorization is done in the covariance matrix. Here it is the scikit-learn implementation of this algorithm. In what concerns dimensional reduction algorithms, we also have feature selection. And here are some of the most used approach to select feature. In the threshold numerical feature variance, the data set has a set of numerical features, and the approach is the following. We start by removing those which have lower variance, and it means like low variance contains little information. So if a variable doesn't in the limit, if a specific variable has a zero variance, it means that it doesn't change, so it is not a variable. In the limit, it is a constant. Here it is the implementation in the scikit-learn, but in practice it is just to create a threshold and and eliminating everything that it is smaller than this specific threshold. For example, if we have some features that are highly correlative, probably they are the same thing, and probably what we have to do it is to remove some of those features that are too correlative. So we may also remove some features that are not relevant for classification. The approach that we may use it is calculation of t-square in the case of categorical features and another f value for the quantitative features. RFE means recursive feature elimination. Here we have RFE-CV, where CV means cross-validation. It is a feature ranking with recursive feature elimination and cross-validation selection of the best number of features. Rising, in this presentation I start by talking about dimensional reduction and two perspectives, feature extraction and feature selection. And in each one of the approaches, some the main algorithms were presented and show how they may be implemented in using scikit-learn.